Hello, my name is Will. Today I'm going to do a recap video of a live stream I did about a month ago. There were some people that weren't able to attend the entire thing and I forgot to record it. So we're going to go through a recap of everything we did during that live stream. And I'm also going to add one additional topic of basic web programming and how web servers work in this video. So as I might have said before, my name is Will. Online, my handle is Sniper7Kills. You can find me on almost every platform using that name. My website is linked here, so if you want to find out a little more about me and my background, feel free to visit there. My Twitter and Discord, so if there's any questions or concerns, feel free to let me know, and I'll be more than glad to get back to you. The topics I'm going to cover today are remote network mapping and the issues that were faced. The next topic is going to be web programming, a little bit of an intro to that. Then we have, as far as occupational, brag sheets and how you can keep track of all of your accomplishments and help you better write a resume. The first thing I want to do, though, is cover this little quote. A jack of all trades is a master of none, but oftentimes better than a master of one. So I am not an expert in any particular field. I have a lot of varied interests, ranging from robotics to web programming, as well as cybersecurity. So I know a little bit about a lot of these topics, and I can apply many of these topics into a single project. But don't rely on me to give you firm, concrete, 100% true facts. I'm going to cover the information to the best of my ability and the best of my knowledge. But if you know something that I'm covering wrong, please reach out to me. I'd love to learn a little bit more about all these topics. So the first topic we're going to cover is remote network mapping and some issues that are faced with it. So the question that was posed to me was, I know Joe's public IP address. Why can't I see what devices are on his private network when I scan it? So the short and simple answer to this is network address translation. And what NAT does is it remaps an IP address space to another. So you have your private IP address space, usually a 192.168.0 or .1.x on your local machines. And then you have a public IP address that anyone can find and anyone can reach. Really what's happening is IP masquerading in most of these situations where you're hiding a network behind a single IP address. So your entire 192.168.0 or .1 network is being hidden behind a single public IP address. So if we actually want to look into how this works a little more, the command you can run is on your local computer is netstat, at least in Windows. So here we can see an example of a netstat on my computer. So you can see I have 3 entries here. There's probably a bunch more, but I just cut them off for simplicity's sake. All 3 of them are TCP protocol. They're all coming from my local IP address. And you can see that they're all sequential ports, 50972, 73, and 74. As far as the foreign address, we can see that I'm reaching out to 2 different web servers because they're both HTTPS using port 443. And we can see that they're all established. So what this tells us is that on my local computer, I had some website locally being requested from port 50972 to the foreign address on port 443. So there's never going to be 2 ports from your local host being sent to the same foreign address or to different foreign address unless they're different protocols. So every connection is going to have its own port going to its own foreign address and port. In my example, you can see that I have 2 different ports going to the same server and the same port. So what this means is that I have a single website doing an asynchronous request for 2 different resources at the same time, causing 2 different ports on my local machine to be used. The way this works in NAT, though, is a little bit more complicated than just that. So if we look at a simple NAT table, this would be what is stored on the modem or router at your house. You have a source IP address, a source port, then you have a NAT IP, which would more than likely be your public IP, and a NAT port. Then to get this out of the way right now, this is not my public IP address. Please don't try to hack into it. I don't know whose it is. So from here, we can see that port 72 on my local machine is being translated into a NAT port of 1024. The reason for this is that if your router tried to keep the same source port from your local computer to itself, you more than likely have conflicts between 2 or more computers. So there could be 2 computers on the same network using the same source port, but the NAT port would be different because there'd be no way to share that single NAT port from the modem to multiple websites or even a single website. So we can see that the source port and IP address from my computer matched my previous slide, as well as the foreign address or the destination and the destination port. The only thing that we're actually adding here is the NAT IP and the NAT port, which is specific to the modem or the router. If we were to look at an example of this, we have the following setup. We have an internal network, a public internet network, as well as your modem, which kind of borders both of those. So if our point 30 computer wanted to reach out to Google, the following chain of events would occur. You'd create a packet, which would have the source IP address of 192.168.1.30 with the source port of 12560, and that would be sent trying to get to Google through your modem. Your modem would add its own NAT port to it, so it can keep track of what ports go to what computers, and would forward that request or that packet after it was modified to Google. At the same time, though, we can have another computer on the network, in this case .50, trying to get to Twitter. So it would have its own source port, which it would send to the modem, which would get added to the NAT table. While this is happening in this example, we also have a reply from Google going to port 1234. So the next step would be the modem would realize that anything coming to port 1234 from the public internet would be going to .30 on port 12560. And it's just a simple translation of this port goes to this computer. And in this example, we're also adding a new entry for .50 going to Twitter using the next available sequential port, which just happens to be 1235. And we can see that Twitter would reply to 1235, and the original entry we had for .30 is no longer in the NAT table because the request was already fulfilled and closed. So there's some other topics that get covered in this, which are going to be a DMZ port forwarding, and one I'm adding in would be reverse proxy and load balancing. So if we look at a DMZ, we can see that anything not in the NAT table would automatically be forwarded to the 1.30 computer. Most home routers are capable of setting up at least one computer into a DMZ zone. And the reason that you would do this is probably for gaming or something like that, where you don't want to have to port forward all these different ports for all your different games. And this would tell the router anything coming to anything not in the NAT table should just come to me because I'm most likely using it. The more specific case would be port forwarding, which a lot of gamers do, would be forwarding a specific port to their computer to another specific port. So in the example I have here is port 8080 going to port 80. Because most home routers and home internet service providers don't allow you to run a website, people that are just getting up and testing and doing development will typically forward port 8080 to their local port 80 computer so they can share their public IP address and have other people give them input on the website they're working on. So that's a strictly one-to-one mapping. And in a reverse look at this, you have reverse proxies and load balancing. This is where a single host will get a request on a specific port, sending it to another server. So in the case of a load balancer, it might be getting a request on port 80 and sending it off to 3 or 4 other computers. So as we know, Twitter, Google, Facebook, they don't have a single centralized computer that all requests are processed from. What they have is a load balancer set up where the request gets handled by one computer and sent off to another computer for processing. That other computer forwards it back to the load balancer to be sent to you after it was finished processing. And a reverse proxy can do something like port forwarding, but on a larger scale and a lot more hidden. So that's more of a website or service provider term, reverse proxy, instead of simply doing a port forward. A reverse proxy can also do it on the same host, so you don't necessarily need to be doing it on a router. You can do it on a web server running on port 443 or 8080, but still accept requests from port 80, automatically sending it to a separate port. A more advanced example of a DMZ would be something like this, and this is what you typically have in a normal organization. where anything not in a NAT table or anything to a specific IP address gets forwarded internally into a private network, which, as you can see here, we have a 10.x network and a 192.168.x network. So the DMZ is the 10.x network, and anything not in the NAT table would be forwarded to another router or modem. And that router or modem, based on the port, can forward it off to specific servers that can handle those specific requests. So in this case, you could have a single public IP address with multiple different servers on the back end. In our case, a web server, a MySQL server, and a mail server. All these different servers can hide behind the same public IP address, doing their own functions. So if you still want to scan Joe's internal network, you are limited to a few options. The best one is to actually go over to Joe's house, plug your computer in with him there, and do a scan. The other ethical approach to this would be to have Joe set up a VPN, so remotely you could connect into his network and then do a network scan. The following two are completely unethical, and I don't condone them in any way, but it would be to exploit the router itself so you can gain a foothold into the network. And once you have that foothold of the router, you can then scan the entire internal network. The other option would be to install a RAT on Joe's computer. And this is just like the router example. Once you have a foothold in Joe's computer, you're on his network, and you can do a port scan from there. The next topic we're going to cover is basic web programming and web servers in general. So HTML is not a programming language, and this is simply because you can't compute the sum of 1 plus 1. A programming language is going to be able to do something, versus HTML is a markup language, which simply changes the way something is stored, displayed, or transferred. So web servers are generally multi-layered. You have the web server itself, which handles the server-side programming and processing. Most of the time, this is going to be in a language such as PHP, Perl, JavaScript, Go, sometimes even Python. In addition to this, you'll have a database of some kind, and this is to store things that the server's going to need. Instead of storing it in files, you'll have MySQL or Microsoft SQL server that's going to speed up the processing and retrieval of this data. Then you also have the browser side, which is going to be, or client side, which is the browser. And this will handle the rendering of the HTML, making the XML formatted HTML file present in a way that's much more appeasing to the eyes, including some CSS additions to it. And you'll also have client-side programming, which is normally JavaScript. So the difference between the server-side programming and client-side programming is you will never see the source code for the server-side programming. All of that gets handled, an output is generated and given back to you. Whereas client-side programming, you'll actually be given the source code for your computer to run, and then the output is changed or visible to you after your computer runs the source code. So the two most popular web servers are Apache and Nginx. And a web server's sole purpose is to accept a request, process the request, and return the output. Some common files that are available or known to almost every web server out there is some kind of index file. The extension may change based on the file type, but the most popular one is index.html. Some other extensions would be PHP, HTML, JavaScript, etc. And these are going to be the default pages that are presented to you if a specific page isn't listed or requested. The next most common file is a robots.txt, and this is basically a do not access list for web crawlers, such as Google, Bing, or etc. And the reason you normally use this, let's say you have some really high quality images. If a web crawler were to go into the directory where they're stored and download them all, you'd eat up a whole bunch of your bandwidth for no reason just to a web crawler. So what robots.txt does is say, any robots matching a certain requirement, don't access these URLs and don't catch them or add them into your database. There's pros and cons to doing this, but that's the purpose of the robots.txt. And just for note, a robots.txt file does not have to be abided by a web crawler, but best practice is to abide by them. There are some web tools that specifically look for robots.txt and crawl and scan the specific things that robots are not supposed to be accessing. The next most common file is a configuration file, and these almost 100% of the time are not accessible via your browser. They're specifically for how the web server should interact with files, programs, and requests. We're going to look at an Nginx example here because that's what I'm most familiar with. So in a Linux web server, you have your root. You also have the etc Nginx folder, which will have a conf.d and sites available folders in them. Conf.d is going to hold all of the configuration files for the web server itself. And sites available is going to hold the configuration files for different websites you're using. So you don't have to have a single domain for a single installation of Nginx. You can actually host multiple domains on a single computer or Nginx installation. The next path is var, which will hold logs/Nginx, and this will be your access logs and error logs that the server generates. You also have a www folder, which is normally where files are stored to be accessed. In my case, I always have a public folder in there, and that is the publicly available folder that files are actually able to be accessed from a browser. As you can see, I have an index.php, robots.txt, and a CSS folder here. Along with the public, I have a vendors folder. There's some tools, just like Python has libraries, PHP has libraries, and normally they're stored in a vendor folder. And that vendor folder is used by index.php and other PHP files, but they're not directly accessible via the browser to a client. So this is a sample sites available for one of my development websites. So if we go through it line by line, we can see that we're listening on port 80. The server name is embassy.os.test, and that is not a valid domain name, but it's something locally I can use for testing. The next line is root. This is telling the web server where the root directory is to present it to the browser. So for my example, it's var www open source embassy public. The public folder is the only file or folder that's accessible publicly to a browser. Anything below it isn't accessible to the browser. The next line is index. These are going to be the index files that will present to the browser. So if we just request a domain, by default, we'll try to find an index.php file. If that's not available, we'll provide an index.html file. And if that's not available, we'll go down to an HTML file. Based on this configuration, we're not going to try to default present a index.js file or anything like that. I'm limiting it into these three specific types of files. The next line is a location line. So basically, this is the root of our domain. So embassy.os.test/. It'll try to find the specific file being requested, and if it can't, it'll forward it to my index.php file with the arguments that are being presented to it. The next thing I have is a little above and beyond the scope of anyone needing to know about basic web programming, but I don't run PHP on the same server as Nginx. I have a separate PHP server that processes all of that. So this entire thing is just saying any PHP file that we're trying to do, send it off to an upstream server that can process it and return us the result. The next line we have is any location that matches the beginning of .ht. So htaccess or htpassword are going to be some basic password protection of directories. And we're saying deny access to any .ht file. Don't allow the browser to load it. The next thing we have is another location. This is for Let's Encrypt, and we can completely ignore this. It's outside of the scope. The next two lines are an error log and access log. And these are saying for this site, where do we want to store the files or the error logs or access logs? So in this example, we're storing them in var log nginx and in embassy/_error and _access.log respectively. So here we can see the actual directory layout of my example. I have a public folder here, and that's going to be the root directory of that domain, embassy.os.test. And as you can see, all of these files here wouldn't actually be accessible to the browser. And here's the actual directory listing of my public folder. So as you can see, we have an htaccess file, a CSS folder, a fav icon, and some other files in there that are meant to be publicly accessible. This is the htaccess file. Again, it's a little nitty-gritty for a basic overview, but just to go over what's possible, you can rewrite URLs. So for my use case, users are only going to be able to access the index.php file. So if there's a URL /something/something else, that's all going to get redirected into the index.php file. And that's, of course, if it's not a folder that exists or a specific file that exists. So as I mentioned before, the robots.txt file usually consists of something along these lines. So you'll have a user agent, which you can specify, Chrome isn't allowed, or Google isn't allowed to access these files, Bing isn't allowed to access these files, or a star would be all user agents for robots. And you can specifically say disallow these files or allow these files, and regex is more or less allowed in that, or at least the star character is. You can also add a sitemap, so instead of the web crawler having to scan every single file and every link, they can access the sitemap and do a very quick scan of your site. The next topic we're going to cover is brag sheets, something that was very important to the Navy, especially when award times came. So why you'd want to keep one is to keep track of your accomplishments. It allows you to quickly build your resume, and in general, it allows you to feel good about what you've done, and as the name implies, brag about it. So there's some things that you always want to keep track of. You want to keep track of when you did the thing, where it was, what it was, who you did it with, what the goal was, and what you actually accomplished. The last two are give or take, depending on your situation, but in general, the what should cover those last two. So how you can keep track of this, simplest method would be a notepad on your computer. If you like the physical version, you can do a journal. If you want to get a little more technical, you can do an Excel sheet and actually keep track and be able to sort through some of those items. And in my case, what I prefer is building a website. That way it's publicly visible to anyone I'm talking to. They can search me up and actually see what I've accomplished. So some of my personal examples was I competed in the National Cyber League. So that was what I did. It was in October and November. So this might be a little small on the video, but I have the time right here. What it was preseason results and individual results, and I provided details with those. And with it being online, I was also able to provide links to my scouting report as well as a certificate of participation. So another example was when I worked at a bank, I did a year in review. So after I was there for a year, I had supported and maintained 15 locations, 600 computer objects, 730 user objects, 20 physical servers, and about 170 virtual servers. So numbers play a big role in this. They show what you were actually doing and what impact it had. I also assisted in resolving 1,535 help desk trouble tickets, and I included what type of issues those were. The reason I used assisted was because I wasn't the only person working on those trouble tickets, and there was a team of us. So I was able to help with at least that many. Those were how many I actually touched. But not all of those help desk tickets were only resolved by me. And if you want to see some more examples, you can visit my website, because that's where I keep my running brag sheet. So jobs with clearances. I had a clearance at one time. I worked at the NSA, and when you do keep a brag sheet, you want to keep it on the high side. So if you're on some type of classified computer system, don't be writing a brag sheet at home. Keep it at work. You also want to do a pre-publish review or pre-pub prior to leaving. Trying to do a pre-pub after leaving can be a pain. Everything has to be written down on paper. If you start writing up your brag sheet on a computer and send that in, well, now if they find any classified information in that, you stored classified information on your home computer. So when you're writing a brag sheet for classified jobs, keep that on the high side. And you definitely want to be doing this because it'll reduce the delays when writing a future resume. So I wrote up a whole bunch of bullet points when I was in NSA, and I got them pre-pubbed. And in this example, you can see that a couple things are redacted. And once that was pre-pubbed, I could then use that basically anywhere I wanted to. I had these predefined bullet points. Versus if I wrote up a resume that got pre-pubbed, if I wanted to change the wording in any of those sentences in my resume, I now have to go resubmit it to pre-published review prior to being able to apply for a job. Versus when you keep a brag sheet, as long as that brag sheet is pre-pubbed and you use the exact same sentencing and verbiage and don't add any additional details, you can just copy and paste that from one location to another. I do want to note I'm not a lawyer. I was not involved with pre-pub in any way. So this is my understanding of it. If you work in pre-pub or you have more information or a contact in pre-pub and I'm not relaying the correct information, please absolutely reach out to me. I don't want to be spreading any misinformation, especially regarding clearances. So when you do this, you're going to have a little bit of an information overload. You're going to have more information than that's usable. But this is good because you get to pick and choose what you actually want to present to other people. And they provide the perfect resume building blocks. So you can actually choose specific items based on the job you're applying to. If you led a team, for an example, in high school, or you were part of some organization and you led it or had a senior role in college, you can actually choose that one thing for a management position you're applying to. If you're not applying to a management position, you might want to choose specific items that talk about how you work well in teams or something like that. Something specific to the job you're applying to. And with this running brag sheet, you can easily choose what you want to put into your resume or what would fit best for the resume versus having to start from scratch for every job you apply for. And this would also allow you to customize your resume to the job you're applying to versus having one standardized resume that you send out to multiple different organizations that might fit their criteria but might not fit it perfectly to the way that you could if you wrote a custom resume. So those are all the topics and one additional topic I covered in the live stream. I'm hoping to do another one in the future, so absolutely reach out to me via Discord or Twitter, or even on my website by sending me an email, and I'll try to cover any additional topics you guys want. At the moment, I don't have any future topics I'm planning on or a date for another live stream and video recording, but if we get some topics that are really good, I'll absolutely look at doing one sooner. So with that, I thank you, and I hope everyone has a good day.